perspective.
That is very interesting.
Yeah.
So hopefully it comes into, well, how about Brian, you wanna?
Do you have
So
any
actually,
questions?
before
Yeah.
Okay, sorry. Go
you're
ahead.
in, I would, so there's a huge amount of work going on in machine learning and applying these things. So I think you're getting into a really exciting area. One thing I would suggest you think about as you start up with these pieces is, and this is particularly important for, you know, it sounds like the financial equation model is really thinking about how these other more technical tools can be applied in traditional finance areas, right? Where, again, option pricing and other pieces when you're trying to replacing the black scholes. One thing I would encourage you to think about is being able to articulate what that improvement is and what the trade-offs are for using that machine learning approach or methodology.
Okay.
And I say this at both my limited work here at FINRA, but also I was at Deloitte for 5 years and at the SEC for 14. There's a lot of growth in these areas.
Yeah.
Folks are going to be really, really valuable in the next couple of years who can explain exactly why, what the advantages are to this particular machine learning technique and why that might justify the implementation risks associated with taking, you know, a black box approach, an approach that might evolve over time in ways that are hard to track. And so I encourage you to keep thinking about that. That's very exciting work.
Yeah, just to briefly, respond to your suggestion. I think that's a really good suggestion. I think I haven't explained that part really well. I guess to put it simply, I think the idea is to exactly give us the interpretability of the black box that we are looking at.
Yeah.
We are all looking at the financial equation. We can, oh, this has this relationship, and that's exactly what we are trying to do.
That's good. That's good. Because I will, in my experience, it's being a little out of turn here, but in my experience, a lot of those financial equations for decision makers are black boxes as well. However, the benefit there is when they're parametric, as you know, you can actually identify what's driving your results. With some of the new technologies, that's harder to do. So that's great. That's exciting work.
Yeah. Thank you. I'll switch back.
Sure.
So Brian is gonna talk to us about the projects. Yes, the one that you did last year. Yeah. With actually with Mitsala. You were on that project with Mitsala. Yeah. And then the one on the second one. The factor also. Factor, yes. And then the one that you're currently working right now on interpretability. Yeah.
Okay.
All the students that you're talking to right now are graduating in May, so that's why they've got lots of experience.
Great. Hi, Brian.
Thanks for taking the time. My name is Brian. I'm from Connecticut.
Okay.
So as Professor kind of introduced here, I'm a second-year student. We're kind of across a bunch of technologies, projects, and topics. So I guess we'll start with kind of the work back in the fall of last year. So Mitsala and myself, and another student, we kind of did an early exploration into the DeFi project you heard about. This was kind of the introduction to that project. So in essence, we kind of did a survey of the Ethereum ecospace and applications kind of traditional finance to those to that space. So I did basically kind of a risk analysis of kind of an IPO of a token, an ERC20 token, and really what that can look like from a risk perspective. From there, simultaneously, actually, I worked with a couple of other gentlemen on applying machine learning models to a classic Fama-French kind of valuation method. And so what that really means is, right, the traditional linear structure of Fama-French, where you just take the weights and the factors and you get this like magical number. Kind of the take there is that relationship isn't actually linear. Further, we don't know what that relationship is. So can we throw it into a black box? i.e. in that case, a neural network, and try to gain more insights. In other words, can we reduce variation in our results by kind of dropping that linearity assumption? And then so recently, to your point about interpretability, we're working with actually an undergrad computer science major, trying to understand how a reinforcement trading algorithm performs over a designated trading space. So specifically what that may look like is understanding how certain aspects of the algorithm behave in certain market conditions, right? During COVID, what are the Q values, for example? Not to get into the weeds here, but what are the Q values of the algorithm doing? When's it buying and selling, right? Are we seeing 3 days of volume increase of 10% leading to more buy calls or more sell calls, or so that's in essence what's going on there. All in the context of sort of visualizing and understanding what the algorithm is doing. And again, as professors, as we've all kind of reiterated, that's all being done in the context of the Python environment for that RL project. Just because there's so much data, we kind of have to, and because it's expensive to train, basically all our testing and our training information is being stored in a BigQuery database, and then we just make SQL calls to kind of our front end to make it pretty. So, for example, a trader who has a quant who built this algorithm can then use that visualization dashboard to understand what his or her model is doing in real time.
So cool, interesting stuff. Are you right? So you mentioned the nonlinearity component of the FAMA French. I guess the question then immediately becomes, how nonlinear is it, and where where the math fails you and the art has to kind of come in, how are you tuning it, and does that get impacted by retraining or other I guess constraints around how you're setting up your feature space?
Yeah, say that one more time. I lost you after the math breaks down.
So right. So you're taking a FAMA French, a very standard, again, linear model to understand performance, and think about performance and pulling out components for potential trading. When you go beyond that, one of the strengths of FAMA French arguably is that it is really straightforward and kind of boxed in and has these fundamental assumptions there. When you move beyond that, how do you manage, you mentioned nonlinearity? How do you actually manage that nonlinearity in a structured way, or even any dynamics if you're layering on either machine learning, neural nets, other pieces? How do you what type of controls or constraints are in your feature space? Just the types of things you guys are thinking about.
Yeah, so specifically, and we sort of saw this in the outcome. So we're not taking a specific equity, for example, and building these FAMA French models to then trade on it. Specifically, what we did is we said, okay, we'll take N number of equities. We took 3 equities, right? The big blue chip kind of things. And from there, we created these valuations, and we said, okay, well, is the portfolio construction, right? Again, we assume just a very generic methodology of portfolio construction, whatever it may be.
Sure.
Just for simplicity's sake. If we compare that same, portfolio using a neural net valuation as opposed to the regular traditional FAMA French valuation, we can kind of derive insights as to how this new approach works against the old approach, right? So there's not necessarily a set of protocols, right? But by benchmarking, we're able to understand the differences the differences in one way of evaluating as opposed to the other way of evaluating. I hope that goes to addressing your question.
No, it does, because I was actually leading to that more general kind of champion challenger framework for thinking about this, right? So using a simpler challenger framework to benchmark any layered on more sophisticated, more dynamic, maybe less interpretable champion model along the way, just so you can then understand exactly what advantages you're getting from those approaches.
And precisely what you find, or we found in this isolated case, maybe it's isolated, maybe it's not. You know, you might get better Sharpe ratios. You might get better, I don't know, you might get higher returns.
Sure.
But at what cost? Interpretability, you know, you're not going to tell a fund manager, hey, I have X amount of return on top of the benchmark using a neural net. Go explain the neural net. Then, you know, a specific factor weighting. That is much more difficult. And if someone's cutting a check for 8 figures, that's not necessarily going to fly. So that's kind of the problem we ran into there. And also what we realized is obviously computing power is an issue, and then optimization. So hyperparameter tuning is a big issue.
Yep.
And not everyone has access to these quality computing powers to address that issue.
Yeah, I'm wondering. Yes, so really cool, interesting. Sounds like you guys are on top of most of this. I wonder if thinking about understanding the market structure from a correlation perspective. I've seen in other instances, big mappings of how equities or similar assets are correlated over time to build in some type of dynamics in order to proxy into some of these models. So you have a kind of a data-driven way to capture dynamics around internal relationships in models. I don't know, just something to think about on the side. But that's interesting stuff.
Absolutely. I'll
You did all 3?
say it again.
You do all 3?
Yeah, all 3.
The smart contractors?
Yeah.
Very cool.
Jack?
Thank you for your time.
Jack Dean. Hi, how you doing?
Hi, it's Jack.
Yep.
Nice to meet you.
Michael Nelson, who's on the Zooms, also on this project, and Jack Gill, who was
right.
here, is as well. But so we're leading. We call it. It's called sports analytics. So before I go into the explanation, just drop all preconceived notions of sports gambling, because that's what we're diving into.
Okay.
In essence, when you look at taking a position in a sports book, it's essentially a binary future, right? So the firm, one of the books has made a market on something, and you can either, you know, take an over or an under on it, or something like that, right?
Yep.
And then its payoff structure, if the asset underlying, in this case player performance, outperforms the set line, and you took the over, you make your money, and if you took the under, you lose your money, right? So you think about it like that. You can combo these positions together, and essentially they mimic option spreads if you do it correctly.
Right.
And Michael Nelson has done a lot of work into this, into figuring out how to do these different ratios and things like that to mimic these option spreads. So essentially what our project is to look for these positions and try and algorithmically take them and then see what the position, the return would look like if we ran it for, say, a week on an NFL season, and just see what happens, right? So the idea is, like, if you were to algorithmically trade these, what does the return look like? Essentially is what we're studying. So
are you able to build an algorithm that actually captures the same trading information from, you know, in a synthetic way?
That's where it gets interesting, right? So, like, in sports gambling specifically, there's no historical database of markets, right?
Yep.
We had to build that, and we have something that can in real time pull data and store it, so we can look at how these lines changed over an entire week, and we can understand how they're moving.
So we have a way of studying that. Our next step is actually going through that data and saying, okay, take this position if this, don't take this position if this, and we have to figure out how to price them as part of it. There are two spreads we look for specifically. One of them is more of a risk-free arb, but it's very uncommon. The
Okay.
other one, it mimics more of a butterfly spread in options trading. And we
Yeah.
have to effectively price strangling the window, if you will.
Yeah. Yeah.
Yeah, that's kind of what we're doing. So yeah, I don't know if you have any more questions about it. I know it's kind of an odd application of this, but it's a new.
Actually, I have to tell you, so we don't regulate that. That's outside of our area,
Right.
but it's really kind of cool. I mean, I gotta, that is, and the fact that you're building out that market, that's awesome.
Right.
It's interesting. So pulling this back to an area we do have interest in. So we have data related to over-the-counter markets.
Right.
And I'm wondering if there's intersection in the type of betting that you guys might see. I have no idea what your data looks like, but outside of the traditional exchange structure, those markets are messy and kind of noisy and lots
Extremely
of
messy.
challenging issues.
Yes.
And I'm wondering if you guys are going to be running into the same types of things and the stuff that you're doing. So that's exciting. That's actually really cool.
Yeah, we're trying to. The goal is to have it kind of put together and be able to say this is the return, these are the assumptions, that's the idea. Now the actual making a bot to actually place the positions on these markets is what's even harder, because the books protect their websites because they don't want our bots doing things. So the goal right now is to get something to tell a trader, hey, make this position, take this position and go. So yeah.
So maybe Michael could talk a little bit what he's done on this side in terms of technology. Michael, can you hear us?
Yeah, I can hear you. I didn't hear what you said though.
Can you talk a little bit about what you did and some of the technology that you used for that project?
Oh yeah, well, so I guess I'd like to bring it back a little bit to the original concept was the fact that the books are so good at what they're doing, like in terms of setting the lines, that we didn't want to try and beat the books ourselves. We more wanted to hedge the books against each other. So that's what the concept came from. And then we did a couple weeks of manual test where we looked for the lines manually just to see if it was a viable strategy. And we found some success with that. So then the next step was to actually build that data set, because there's no data for it, because they're so protective over their data. But yeah, the big thing that, along with accumulating data, the other thing that we've been working on most is assigning probability distributions for the players to determine if the window that we're seeing when we're hedging the two books against each other, if it has a positive EV, so if it's worth taking. And the difficulty is it's easier said than done to assign a probability distribution to a single player's points that he's going to score in a single night. You don't know what matters and what doesn't, because there's so much that goes into it.
And going along with that, it also depends on the sport. A sport like baseball, it's a little bit easier because you have a lot of data. A sport like football, it's a lot harder because there's a lot less.
So, and the one of the contributions is you're actually you can see how books hedge against each other, right?
Yeah, we can see in time how they're moving. Yep.
And you can do that across sports, right?
Yeah.
I guess it doesn't matter. It doesn't really matter what they're betting on once you have
the only concern that you have to understand, I guess, from that side is, so the sports trading desks for the sell side in this case, are based in are either in New Jersey or Las Vegas, but they're controlling the books in every state. So there's some regional issues here. So like, let's say so we're in Pennsylvania, right? So, you might see some kind of weird action going on the Philadelphia Eagles or any player on the Philadelphia Eagles that you would not see if you were in what's another state with legalized camp like that? I gotta think of Jersey. So like if you were in Jersey, good example. If you were in Jersey, you might see a different line than if you were in Philly, because state by state, it's technically a different book. but the same trader is setting those lines. So that's another issue you have to.
So are there arbitrage opportunities between those?
Between those, yes. Typically, it's across books. So if, say, like say FanDuel has priced a line at something, right? And they
Yeah.
give you plus odds on an underside. So in
Yeah.
other words, if you put $100, you're gonna get 100 and some back.
Yeah.
If the under hits. DraftKings might give you plus odds on the overside
Okay.
for the same line in a
Okay.
different region. And if you can take that market either way, if you put $100 down, you're getting more back on each line.
It would be interesting to see if long form if those markets are efficient long form. So maybe there's arbitrage opportunities in the short run, book by book, but on average, there may not be. That would be really interesting.
That's a good question. It really all depends on what the books are doing, because unlike in an over-the-counter market that you would see on the finance side, there's only a couple of books, and they don't really like to tell others what they're doing.
So my regulator hat would ask you guys to think about another question that maybe you can answer with your data. Is there information leakage around the books? So is there evidence of collusion in any way? I don't know how that would show up, but maybe some natural experiments around whether on average these guys could have done as well in some instance. I don't know. You have to think about that, but given their informational advantage, I don't know that over the years, that always like gets my spidey sense kind of up and going, because it's like, well, if you guys are in this club and you're making this money at the expense of the others, what's stopping you from doing it? So that it sounds really cool. We could talk about this for hours, but yeah, this sounds really cool. You guys are doing great stuff.
Thanks.
Cool.
Thanks, Jack. So why don't we do Shitali for a little time, maybe less than 5 minutes. I mean,
Okay.
Shitali actually now, she just joined the program, believe it or not.
Okay.
She started working on it during the summer on this Bitcoin trading strategy, again with the same author that Yaron is working on. Maybe you could give us a quick overview of what you've done so far, some of the technology and what you're trying to achieve.
Okay. And it's Shitali?
It's Chaitali, yes.
Shaitali, nice to meet you.
Hi, Harvey. It's nice to meet you too. So yes, I joined this fall, first week at Lehigh.
Mhm.
And so Kiran Ramos,
Yeah.
Ari and myself, we're working on a Bitcoin to the strategy project.
Okay.
So the book by Hariom, that's Machine Learning Data Science, already covers major chunk of it. Obviously, the black box issue. So he expects us to kind of thread the models using artificial neural networks. Thanks to Hariom, he's kind of he wants us to right now currently work with Lime and Sharp to kind of thread the models. Shapley values in game theory.
Oh, the Shapley values. Yes.
So,
I'm sorry. And what are you looking for with Shapley values there? Is it model drift?
So we're trying to interpret the model and the how accurate it is with the Shapley values. Kiran is working with Lime. I'm trying to work with Sharp, and so far we've been trying to kind of get everything together and work on a smaller database, because initially, obviously, one of the I worked with was growing up, because Bitcoin has been relevant the past 5 years. We're trying to cut down things, and yeah. So
Cool.
hopefully it should be fine with the coding and everything in the coming few weeks. But
Okay.
yeah, it's good.
Great, thank you.
Very good.
Remus also is joining the program, and he's also already working on a project called, you tell him what you're working on, it's interesting.
Hi, Harvey. My name is Ramos Wu.
Hey, Ramos.
Students from China. And then, I guess we started working on this project. It's actually proposed by Professor Nandu Mayer.
Yeah.
And then, what we're trying to do is we're trying to create a Pennsylvania economical index. So
Okay.
what we do is we're trying to grab all the publicly traded company that's in Pennsylvania. So at the beginning, we do have some problem trying to filter out those companies, but we got some approvals, got a premium subscription of Alpha Vantage. So what we're trying to do is at the beginning, we try to look at what other schools has this kind of index or what kind of index they have. But most of the Ivy schools, which is Lehigh's competitors, they only have pretty raw data, just rows of numbers of how the S&P 500 is doing, but we're trying to make it a little bit better. And by better, we're mostly focusing on how do we make the whole thing automated? And also how can we make a interactive platform to make it a little bit user-friendly and for everyone that can easier to locate what kind of information they're trying to grab. So in terms of the automation, we built a data pipeline and trying to keep going back to our source, which is the NASDAQ.com, trying to see if any companies are entering Pennsylvania or if there's any mergers or buyout. We could typically set the time range. Right now, it's like for a week. So every week, the list should update. And then by using that, we have some complex Python code to make sure that every time we grab a new company, there's going to be new value. And so far for now, we're just showing Pennsylvania economical value by showcasing the market cap. But later on, so right now we're in the stage of trying to host this whole system onto the Lehigh website. But later on, we're trying to implement a little bit more features, kind of like more of a financial analysis behind it, different ratios, and also maybe have like relative news. So it's just less of a academic research, more of how we can push this product out and for people to use it. Yeah.
Great.
That sounds cool.
Thank you so much.
And you know Nandu, Naya.
I do.
Yes. Okay, so
I do.
next I wanted an interesting, it's not a project, but Jack, Jill, maybe Jack, you could come in front, and Michael Nelson actually embedded for the next 3 or 4 minutes. Maybe you guys could explain a little bit what you guys do over at, yeah, Jack.
Sure, I can start. So, I think Michael and I are somewhat limited in what we can talk about for confidentiality reasons, because we've been kind of helping work with this fintech startup. And the idea